How do you figure out how many chiral centers there are in a molecule? This really just comes down to being able to find chiral centers and then counting them for the entire molecule. How do you identify a chiral center? You need to find atoms that have 4 different things attached to it. So it's got to be 4 things, and they all have to be different. Lone pairs count as a thing here. Let's go through this molecule, see if we can find atoms that have 4 different things, because those are the ones that are chiral. Now, it may help you if I draw in the extra hydrogens that aren't shown here. For example, this carbon has 1, 2, 3 bonds to it already. That means a bond to 1 hydrogen isn't shown. Now, that's going to be the same for all of the atoms around benzene. And if you know benzene, you already knew that. This carbon here, 1, 2, 3, 4 bonds already, so it's fine. This oxygen has 2 bonds shown. That means 2 lone pairs are not shown. This carbon is missing 2 hydrogens because it already has 2 bonds shown. This oxygen is missing 2 lone pairs. This nitrogen is missing 1 lone pair because it has 1, 2, 3 bonds shown. Nope, that's 3 bonds actually. So I gotta draw in a hydrogen here. 1, 2, 3, 4 bonds to this carbon. 2 bonds to the oxygen. Nitrogen needs a lone pair. 2 hydrogens to that carbon. 3 hydrogens to each of these. That's a CH3 group here. I guess I could have just drawn CH3, but oh well. This sulfur needs 2 lone pairs, etc., etc. And actually this hydrogen needs to be shown as well. Okay, so all the atoms have their 4 things around it. They satisfy the octet rule. Let's start counting. See if we can find atoms that have 4 different things attached. This carbon is attached to this carbon twice, and this hydrogen. That's not 4 things. It's attached to 3 things. That's attached to 3 things. 3 things, 3 things, 3 things for the same reason, and 3 things for the same reason here. Another way to put that is that if there's a double bond, it can't be a chiral center, because it needs 4 different things. Oxygen is connected to this thing, which are clearly different from each other. And then it has 2 lone pairs, but the lone pairs are the same, like that lone pair is the same as that lone pair. So it's not 4 different things. This carbon, 2 hydrogens, which are the same, not chiral. This carbon, only connected to 3 things, not chiral. This nitrogen, connected to this chain, this square thing, a hydrogen, and a lone pair. Hey, that's 4 different things. This chain, that square thing, the hydrogen, and the lone pair are all different. That means that is a chiral center. That's 1. This carbon is connected to an NHCO, CH2, whatever. It's connected to this square this way, and the same square this way. Now, when you go around the square, it's not symmetrical. So these 2 branches count as different things. Put another way, if you go this way, you encounter a CHSN, like a carbon connected to hydrogen, sulfur, nitrogen. If you go this way, you're connected to a carbon that's connected to nitrogen, oxygen, oxygen. Those are completely different. These carbons are not the same. So this carbon is connected to something different, this way, that way, that way, and the hydrogen way. That means it's a chiral center. Only connected to 3 things, not chiral. Connected to C double bond O, C single bond S, CH2, and lone pair. Those were all different, chiral. This thing's connected to CHN, CO, whatever this branch is. It's connected to S here, N here, and H here. It's chiral. This carbon is connected to 2 hydrogens. Those are not different, not chiral. This guy is connected to CH2N, S in this direction, CH3 here, and CH3 here. Those two methyl groups are the same, not chiral. And this sulfur has two lone pairs, so it's not chiral because they're the same. I think we've gone through all the atoms. Maybe not this oxygen, but it's only connected to one thing, so that's it. All right, so we found all the chiral stuff. 1, 2, 3, 4. We have 4 chiral centers. Hopefully this video helped you learn what a chiral center is, in addition to me just doing it for you. I want you to be able to find chiral centers yourself. Rewind this video and tell me whether or not they're chiral before I tell you. Good luck and best of luck. Yeah, that's what I say. Take care.